and we are live.
Hello everyone, welcome to the webinar How to Build a Successful AI Business that will be presented by Tristan Post, an entrepreneur and a lecturer in AI. So first, let me start by explaining you what is Data Scientist. Data Scientist is a company that was created in 2016. It trains individuals and companies on all data-related topics. So with Data Scientist, you can train to become a data analyst, data scientist, or data engineer, and even other jobs that are related to data science. For more information, do not hesitate to consult our website, datascientist.com, or go to our social medias on YouTube or Instagram. I am now going to let Tristan Post present you how to build a successful AI business.
Perfect. Tom, thank you so much. So let me see that I can share my screen. So 1 second. Okay. Are you able to see my screen?
Yes, we can.
So now you should have kind of like be there. So yeah, very happy to be here today talking about how to build a successful AI business. I will tell a little bit about myself in a second, but normally how I like to start kind of like also my lectures is to give you a bit of a background on why we are here at the place where we are now, because I'm not a programmer, but I'm an economist by training. And I always like to think kind of like, how do we get here? Or what happened did we get here? And I always like to start at the very, very, very beginning and think, okay, what makes us special as humans? And there are a lot of things that makes us special as species, but one of them for me sticks out remarkably. And this is our ability to not only use tools, but build and develop new tools. And the development and the building of new tools is what I call, or for me, is technology. And it's very interesting to see from an economics perspective, there's a special kind of technology we are always getting very, very excited about. And that's what we call the general purpose technology. And a general purpose technology is a technology that can affect our entire economy and has the potential really to drastically alter our societies, as we are seeing obviously now with ChatGPT. But in our very short human history, we have a lot of examples of kind of like these general purpose technologies. And what is remarkable that most of these technologies always have helped to augment our physical capabilities. Think about the written language, how it augmented the way how we communicate and write, the plow augmented the way how we do agriculture, then also kind of like the printing press augmented the way how we copy books, the car augmented the way how we travel from A to B. And only very, very recently do we have the ability to augment our cognitive capabilities, only with the advent of computers, so less than 100 years. And the exciting thing about our ability and about AI, the ability to augment our cognitive abilities, is that our intelligence is one of the requirements to develop new tools, so to say, for kind of like bringing out technology. Something else, what is very interesting to see if you look at general purpose technologies is at the beginning, they're often very, very basic and they become much more sophisticated over time. So think about, let's take the example of a printing press. Back then, it took a lot of people to deploy a printing press. Now in the developed world, over 50% of all households have an own printer at home. Or think about a car back then, and now we are almost kind of like on the verge of self-driving cars. The same we have in the world of artificial intelligence. I mean, we have been talking about AI since the 50s. Back then, the Dartmouth Summer Research Project, where they believed they could basically automate or kind of like use machines to mimic the way how we learn, and by this we could kind of like improve our intelligence or build artificial intelligence. Turned out it was not that easy. They planned it, they thought they could do it in a couple of weeks. Turned out it was not that easy. And it took a couple of decades for them to have kind of like the first real breakthrough. And for me, one of the big breakthroughs is when IBM Deep Blue, the first algorithm, was able to beat the world ranking champion in chess. And what is so interesting about this is, I mean, in chess, you have kind of like fixed ways how you can basically move your pawns. So because of this, you have limited choices. And because of this, you can use brute force and actually calculate what would be the best move. So it was relatively easy. Compared to this, many of you might not know the game of Go, but it's very famous in a lot of Asian countries, similar to chess. But here, the only difference is that you have black and white and you don't have those fixed rules. So basically, you can place those stones on any part of an intersection on the board. That means that you have more possible combinations of how the play can look like than there are atoms in the universe. That means you can't use brute force anymore to calculate this, but we needed a new type of algorithms, machine learning algorithms, to solve this. And this will kind of like be also important later on in the talk when I talk about why this matters in building a successful AI business. But what I wanted to show, just kind of like to get you a bit going and excited, is for me, this is was one of the defining moments in the world of artificial intelligence, when we see now, I show you like a small example from the second game, where they managed to build an algorithm that was able to beat the world ranking champion. And I would want to show you one kind of like just one move of the second game, where it was for the first time where they said that the computer showed something such as creativity. And I hope the sound works. And I think this is very interesting to see, because now we are actually in the age, or in the middle of the age of artificial intelligence. And we will see more and more often that AI is kind of like coming up with new ways to do things and surpassing even our human capability. And I think this is very true, what one of the founding fathers of the deep learning algorithm said, that AI is the new electricity. And just as electricity transformed almost everything 100 years ago, each industry, we will be seeing the same with AI, and actually now with ChatGPT, this is really becoming true. So I'm very excited to be here today, and then to talk about how this technology can be used to build a successful business. So a little bit about myself. I'm an entrepreneur. I also run the biggest AI startup incubator in Europe called AI Founders, which is located in Heilbronn. I'm a lecturer at the Technical University of Munich for AI for Innovation and Entrepreneurship. I'm a lecturer at the Munich Business School for AI and Business. I'm an AI strategist, so I worked with the big companies in Germany, BMW, Siemens, Zeiss, on their AI strategy, helped them to build up the capabilities to do artificial intelligence. And I advise startups, investors, private equity funds on all kind of like topics when it comes to artificial intelligence. So I'm very excited today to be here and now finally really talk about what I wanted to talk about is building a successful AI business and really what it takes. And for me, building a successful business is very similar to trying to land a man on the moon. And I will kind of like leave this a bit as a cliffhanger. And at the end, I want to show you why I believe that building a successful AI business is like trying to land a man on the moon. But first of all, I want to think what makes a good business, right? And everything starts with an idea. And what is a good idea? A good idea is a mental representation of a potential solution or opportunity which serves a very specific need. And I believe really to build or to have a good idea that you want to build a business out, it takes three factors for this idea or this business to be fruitful. First of all, you have to build something that is desirable, so people really want to use it, so you have a user for it. Not only do people want to use it, but you need to have viability. So people need to pay basically money for it, so you can afford doing what you're doing, and also maybe afford your cost of living and paying your employees and so on. So you need not only there needs to be a desirability, but there needs to be a business model, and people need to want kind of like, or users need to want to pay money for it. And lastly, you need to have kind of like the feasibility. And this is the technology, but also the operative model. So are you really able to build what you do? And you can think about if any of those three is lacking, it's not working, right? So if there's, I don't know, so if there's no business model around it because you're building something that people can get for free, you will not make any money. So there's no business there. If you have something, you're building and working on something that no one wants to use, you can have the best product, but if no one wants to use, then no one's going to use it, and at the end, no one is paying for it. So I really think it's essential that you need to have those three. Or even think about, I mean, there are a lot of startups that are working on self-driving cars. None of this is really successful in terms kind of like none of them is really making money. Why? Because we don't have the technology yet to have fully automated cars on our street. So we don't see any successful business at the moment at self-driving cars. When we have kind of like solved this, we will see a more successful business, but at the moment we're not there yet. So you will not find any successful self-driving car company that is cash flow positive. And I think these three criteria are very important, plus one additional one that we have to think about. And I mean, this is nice, and you have to think about, do you want to scale it or not, right? So any business, you have to think about, do you want to scale? So if your number of customers increases, how do your costs relate to it? Do they increase with the number of customers, or do you have really a scaling business? And it's completely okay to not have a scaling business. I mean, there are a lot of consultancies that work on projects, and they are very, very successful and very beneficial, but they don't scale well. And often when it comes to, for example, you want to build a business, you want to build a startup for AI, investors want to see that you have built something that you can scale so that you can invest in. And this is something we're going to talk later about. But right now, I just have been giving you some context on how to build a successful business. So what about the AI part? And I'm not sure kind of like of the people in here, but maybe this is going to a bit slower. But I really kind of like want to make clear to show you, okay, what is the difference between traditional programming and AI or machine learning, how we call it, and how this really makes the difference. So what about the AI part? I mean, AI is very easy explained. We have an input, we have processing, we have output. So take, for example, emails. You have a spam filter in the middle, the AI part, that takes emails that come in and sort them in spam or not spam. So what is driving everything behind AI is nothing else than algorithms. And algorithms is a step-by-step guide procedure for solving a problem or reaching some conclusion, especially by a computer. So, and we encounter algorithms everywhere. So it's super easy to understand. One example would be a cake recipe. Another example would be this blueprint on how to put together the Lego thing. So just think about it. You have an input, you have the Lego stones, you have your algorithm that tells you how you have to put those stones together. You, as a person, do the processing, the computing, and out comes this really nice Lego penguin. And what is very interesting, I mean, we have in the world of AI, we have mainly two kind of algorithms, rule-based algorithms and machine learning algorithms. What I have been talking about now is an example of rule-based algorithms. And often if you tell people that this is AI, nowadays they will say, well, this is not any fancy new cutting-edge machine learning, but from the 1950s to the 1980s on, everything that was happening in the world of artificial intelligence was built on rule-based algorithms. The problem with this is at some point they realized they hit a barrier and they were not able to really kind of like do a lot of the cool things they wanted. And the reason for this is if you do rule-based algorithms, you really have to know the rules in advance and you have to hard code them into your solution. But our world is actually very, very messy. It's very unstructured and it's really non-deterministic. So for a lot of things, there are not any rules. So it's really hard kind of like to describe what actually is happening because there's so many exceptions. And above all, we have something that we call Polanyi's paradox. So a lot of forms, a lot of tasks that for us seem very intuitive are actually very kind of like, for example, holding a glass of water and drinking it. We don't really know what the rules is. We just do it. This is millions of years of evolution have kind of like just made us be able, for example, on the street to see and understand this is a car or there's a cat crossing the crossway and so on. But for us, it's very hard and difficult to formulate those rules. So it was very kind of like problematic. And along came machine learning. And nowadays, when people talk about artificial intelligence, they always mean machine learning. And within machine learning, obviously, we have now neural algorithms, not just deep learning and so on, but they're all part of machine learning. And here, it's fundamentally different. Instead of us basically telling what the rules are, we let the computer figure out by kind of like showing them a lot of examples. So let's take one example. So we want to teach a computer, an algorithm, how to kind of like read handwritten letters. And this is something, if you think about it, it's very difficult to come up with the rules because as you can see, sometimes, so I'm from Germany, these are all the ones. Sometimes we write in Germany a one that looks very similar to a seven, and they all look slightly different. So what would be the rules? What makes something, some things very hard to program? So instead of kind of like figuring out, thinking out what the rules is, why don't change the whole problem and feed the program a lot of data, a lot of examples of zero and tell the computer, okay, or the algorithm, this is a zero, this is a one, this is a two, this is a three. So we're taking a lot of data and say what the output should be. And then the algorithm figures out for itself the underlying patterns in the data that make out of these kind of like squiggly lines a three, a two, or one. So then it can come if something that has never seen before and say, okay, well, based on the rules that I have learned, based on the data, what I see now is six. So if we have to compare this, what is the difference between kind of like this traditional programming and machine learning? Here we have an input, we have a program that is written, an algorithm, and then we do kind of like the computation, get the results. So we need to have someone who knows in advance the rules. In machine learning, it's completely different. The input is a lot of data. We say what the desired output should be, and then the machine learning does the training for itself. So it does the computation, it figures out for itself, and then it writes the program. And based on this program, we can put a new input the computer has never seen before. So why am I showing you this? Why kind of like making this big X course? Because I think this is very fundamental to understand when building a successful business around artificial intelligence. Because when we want to kind of like very, very simplify it, so we have on the one hand side rule-based, which is just code, and then we have machine learning, and everyone nowadays call machine learning AI, even though some rule-based algorithm for me would also be artificial intelligence. We have code and data. And with this, we can now adjust our mental frame of kind of like what it takes to build a successful business, and this time for AI business. So we see that kind of like the technology part is not only code anymore, but code and data. And we're going to use this in a second to show you, I'm going to show you what are the challenges for any AI business to become successful and how to overcome this using kind of like this mental model. But before we do this, I want to kind of like show you in the first place what different kinds of AI businesses are anyhow out there. So for you to understand maybe what kind of business you want to build. And I think essentially there are 5 different kinds of businesses you can build around artificial intelligence. The first one is AI consultancy. For example, I work at Applied AI. What we do is we come in a lot of customers, and every time we build something new for them, we teach them, we advise them, and so on. And you see a lot of AI consultancies that are coming out there that might not have any standardized product. It's still a business. It's still, they're making good money, but they don't really scale well because every time they come in a new product, they have a new customer, they build something new, they start from the beginning. It's very person intensive to have a business like this. Then you have data analytics providers. So these people use artificial intelligence to extract information in your company, wheresoever or something. One prime example for this is Celonis. This is this German decathlon, super famous, one of the most highly valued startups in Germany and also in the world. And they use basically AI to give you input or insights, data insights in how your process are actually working. Something else is the AI development facilitator. So these kinds of businesses or startups help you often with a no-code solution, help you to build your own AI or use their tools to easily build artificial intelligence. So one example would be out of our batch Trail, where they have something where you can easily track experiments and get better insights in your data analytics process, make it more transparent. And then I think this is what we quite often see. We have an AI charged product or service provider. So they really use AI as part of their product. And it can be kind of like more as an enabling technology or really core technology. And one example for this is the Munich company Park Depot. So what they have is very basic AI functionality technology. So they have cameras, and with those cameras, they basically detect your cars, and they manage car parks just using your cars, and can tell when cars leave and how long they stayed. And they do everything now completely online, and it's super easy with their technology to manage cars. And the last part is the deep tech providers. And these are the companies that really build cutting edge AI technology. One example is OpenAI. So GPT-3 is a deep tech, is one example of this. What OpenAI have built is kind of like this deep tech provider, and ChatGPT would be an example of an AI charged product that is built on this kind of like deep tech provider. So it's not only because like you don't have to be one. We see often also that AI consultancies are building at some point a product that they use, but just for you to kind of like a little bit to understand what different companies or types of AI businesses are out there. And this will kind of like also help us better to understand what are the challenges or maybe what kind of business you want to build. So what are common challenges that we see? And I said at the beginning, let's use this mental model that we have created. So this mental model on how to build a successful business adjusted for AI. And I tell you, there are 3 main challenges that we see quite often in the market. And the first challenge that we see is there is no product market fit, or it's very difficult for a lot of those businesses to find a product market fit. And what is the reason for this? The reason for this is often the companies or the startups that are getting started, they come out straight out of university. They have developed maybe something very cool, some very technology heavy, and they're very focused on the code. And something that's very hard to get is the data, but also they don't understand. And we have this very often, the smartest people ever, and they have developed something very cool, something kind of maybe more explainable AI, or I've seen very smart people straight from university, PhD, developing causal AI, but they are having a hard time really kind of like to build out of this a product that people want to use and that they can monetize. So one thing that we see often is very important to have also these business-minded people in a business when you want to build it, because many come just from the technology side and have a really hard time to find this product market fit. The second thing that we often see is those startups are difficult to scale. And mind me, I mean, if you are a consultancy and it's not your goal to scale, this is totally fine. It's completely a valid business and so on. But we see when I speak with investors and they want to invest in your business, is often something they're looking for, and they often have this really hard time to scaling for one reason, and this is for reasons out of data. And the reason for this is often if I'm kind of like work on something, the data that I have largely varies depending on the customer I have. And I brought one example with me. So this is one of the examples of Porsche. So what they have been doing is kind of like they kind of like have been applying microphones to listen to their cars, to kind of like understand, depending on changes in sound, if certain things in the car are broken. And imagine you are now a company that does the same thing. So you are basically an AI sound detective tool. And now you go to all the car manufacturers and you want to build a product of this because you have kind of like developed these cutting edge things. Now you have to think about that each new car that you have, each new customer that you have will have a completely different sounding car. Each new car is completely different. So, I mean, there could be a lot of money for you in doing this, but it doesn't really scale very well because each time you're coming in with each new car, you have to retrain your models, which can be costly. You have to fine tune everything, which takes a lot of kind of like human resources. So this makes a lot of the business very difficult, very hard to scale. And I mean, in our batch, we're the largest startup incubator in Europe, AI founders. And we see every year, there are a lot of companies that focus on predictive maintenance using something on the assembly line. And I think each batch, I see at least 10 startups that are trying to apply. And from the beginning, I know they will have incredibly hard time to really scale their business. So basically bringing it from the one customer to the next product without having this huge cost in customization, retraining the model. It always takes a lot of people to do so, and they just don't scale very well. And they are often not very attractive for investors. So this is something I really want you to think about when it comes to kind of like developing or building your AI business. And I think the last point is what about a long-lasting unique selling point? And I think right now we are really in a prime time to really understand what this means. So if you think about if I've built a model a year ago, I mean, by today it's probably commonplace, and there's something that supersedes this model. Just look at, for example, has been over the span of a year, the huge jumps we have in image generation capabilities. So this from March 14 to March 16. And I mean, when you have kind of like technology, cutting edge technology, how can you be sure that this will not become commonplace? Or look, just kind of like maybe you have been building your incredible language tool, and we see it right now. There's so many language tools popping up from all sides. So how can I use this really to maintain a long-lasting selling point? And we see this is now a challenge of a lot of kind of like established companies that right now this is happening. So here is, for example, Lexalytics or Basis. And what they had to do before is mainly they used data that was publicly available, and then they had a big team that built around this data, their own proprietary AI models that do NLP and read this. And based on this, they provide kind of like value for their customers. And here, Basis is just another example. And we saw this in our batch. We just kind of like started the second batch, and we had over 200 applications. That was in March or late February, and 1/3 of those companies, they basically started to use or wanted to use APIs from OpenAI. And they were doing, suddenly wanted to do things that kind of like long established companies really wanted to do. And then there's the question, where does the long lasting unique selling point come from? Because now I have any company, I can use the same data, and then I use GPT-4 or one of the new language models. And these language models are much better than others have tried building up with teams over a long time. And therefore can probably provide much more value. And we have now a lot of very different use cases. So that means the models can't be the one that add value anymore. And I think just kind of like very important to understand where the value is coming before. So this was kind of like before, right? So you had different models that you could use depending on your expertise, and you had kind of like if you had different data or your proprietary data, the value added was kind of like different, and there was kind of like your competitive edge that you had. If you had the same data but had maybe a different model, there could be also different value that you added. But now in a new world where we have now with the large language models, everyone is basically using models that are more or less the same and more capable than what everyone else has been building. If you use the same data, you will gonna have the same value add. So your value proposition is gonna be very low. But really, it comes down, interestingly now, much more to the data. And just as an insight, it's also very interesting to understand that even the big companies, and this came out yesterday, even the big companies, Google, thinks they have no moat, they have no defensibility on the models that they're building, and neither does OpenAI, because now it's coming out more open source and open source. So what does this mean if I really want to build a successful business around artificial intelligence? I have to go away from the code, and really the model that I'm building is becoming less and less important, and it becomes more important the data. So what we're talking about is kind of like data-centric AI, because data is very difficult to replicate and to copy. And then is the question what we're looking for, or what I'm looking for with our work with investors and look into AI businesses they want to buy. What is the data? How they're using data, how they can use data to generate additional value in the future. And something I also want to kind of like show, I think was also important to understand when it comes to building a successful business tailored around artificial intelligence, is on the one hand side to understand there is kind of like this AI value chain, and how all of these factors, so how the foundational model that you're using, maybe now ChatGPT, GPT-4, and so on, play a role, and that you have to kind of like fine tune them based on the task that you want to do and on the data. The question is, do you need computing resources for that or not? If you use the API, you have to pay for this computing cost, obviously, but also very important, it's all about the access point, right? So how do you using AI to create value to the customers, to attract your customers, to get to your customers? And there, AI plays only a minor role. But because if you think about it, it's all about kind of like the product that you're able to build around artificial intelligence and the operative model. And just to take an example, and again, looking at Park Depot, what they did is, they have kind of like these cameras that they use. With the cameras, they recognize which car you are, and based on your license plate, they can recognize you, and they help you with the car management. The technology they have built, look at this. Even if I'm a first year data science student, I can build a license plate recognizer. Super simple. So this is not the value that adds, but the whole product they have built around it, the customer experience, the user experience around it, the service they provide on top of it, the whole operative model, that people really want to use the product. And this is something that we often totally forget and underestimate when it comes to building a successful AI business, that the AI part is not so much the important part, but really this whole deal, this whole package, the whole data. And in this instance, it's also kind of like important to understand how you can build a product where you actually capture more and more data, because we said this data is really something that's really hard to replicate. And maybe some of you have heard about kind of like this flywheel of artificial intelligence, where you have with more data, you are able to build new algorithms, better services, and new services. And with this, you attract more customers, you're able to generate more data, and so on. You really have this flywheel. And just saying kind of like how important it is to understand that AI is just one minor part. And this brings me really back to kind of like the teaser that I had at the beginning. And here is actually why I believe that building an AI company, an AI business, an AI startup is very similar to trying to land a man on the moon. Because, I mean, you need the astronauts, and the astronauts are, for me, the AI part. I mean, everyone talks about the astronauts. The astronauts are the heroes. But to be honest, the astronauts are the role of them is hugely overplayed, because you can exchange them, you retrain them once they get old, you get new astronauts, and people often overlook the real importance, because what is an astronaut without his rocket? And the rocket really stands for the product. And if you think about also kind of like in the development of the product, often we see that the AI part takes very small role. It's really easy and often fast developed, depending on the product that you're building. And what is vastly more important is actually the product that you're able, or the service that you're able to build around artificial intelligence. And for this, obviously, you need kind of like a really, really competent team that is able, not necessarily anymore so much on the AI side, because now you have these big foundational models that you can easily use, but kind of like on the operational side, on building a good product that people really want to use. And now it's becoming much more of team effort, because you need your UX designers that can kind of like generate a nice customer experience. You need your business people that know how really kind of like to operate such a business. You need your salespeople and so on. It's kind of like the real deal. And never forget the big team that actually built the rocket, that trained the AI people, and that made kind of like that landing on the moon possible. But really, really, really never lose sight from what you actually want to do, the end value you want to generate for your users. So never underestimate and never leave kind of like your main goal out of your eyes. And this is kind of like, how can I use AI to build a product that really adds value to the users, the people who want to use it. And this more or less was the end of my presentation. I'm trying now to come back and see somewhere where the screen is. And I hope it was interesting and insightful. And if you have any questions.
Um,
Glad you liked it, Frederick. Tom, do you know if there are any questions? Then if there are no questions, I'm really glad you liked it. I hope you enjoyed the talk, and it was interesting, it was insightful. Um, um, it helped you in understanding what it takes to build a successful business around artificial intelligence. Please follow me on LinkedIn. I mean, I post a lot of this stuff. Follow also our incubator if you're interested at some point. I hope we can help you building your startup. AI Founders by Campus Founders, it's called. And I wish you a great day. Yes, looking forward to see your businesses that you build around artificial intelligence.
Many thanks to Tristan Post for hosting this very interesting webinar. Thanks also to our followers, and also don't forget to follow Data Scientist on LinkedIn or YouTube to watch new events. Have a great day. Goodbye.